Right. All right. So, good afternoon, everyone. I'm Sandeep Giri. I'm going to continue the session where we left last time, and we were discussing we discussed till HDFS replication and how name node avoids bottleneck. All right. So, just a quick overview on how does the communication happen is the client goes to name node for the metadata operation. So again, a little bit of recap. Name node is the one which keeps the metadata such as file name, directory name, file permissions, replication factor, block size, all of this data related, the actual data of the file is not in name node, but this metadata which contains the information about this file is in the name node. It serves like an index containing pointers to various data nodes. All right. Now, data nodes essentially contain the actual data. Say if you have a movie, the actual bytes of the movie is in the data nodes, and that too broken into blocks. All right. So now, the dynamics of a file write is like this. HDFS client, this is the client. You as a user will be calling the HDFS client. It's a command line for now for this discussion. You ask HDFS client to put a file, save my file onto the server, right? Say you want to upload a file to HDFS. So what you did was you asked HDFS client to upload the file. Now HDFS client will first talk to name node. Okay, will talk to name node and will create the metadata. Okay, it'll create the metadata. Also, it will mark that the file is being written. Once it has done that, the next step is to start writing the data to one of the data nodes. So it will write that block onto one of the data nodes. That data node will start copying the block to another data node, and then another one. So this is basically making the replication the of the block you are putting onto a data node. Now, once a block is done, once a file is finished, once all the blocks are done, just like this, all the nodes have written the data. What we need to do is we need to close the file and tell name node that hey, we are done. So in metadata, it will be marked that the file has been completely uploaded. Why? Because in case HDFS client fails to upload the data here, in case because there is a distance, imagine that HDFS client has straight away told name node that hey, we are done creating the file. Okay, and then it uploads the data. What will happen is if HDFS client fails to upload the data, name node will think that still there is a file, and when user comes to ask for a file, it'll give a wrong results. Second, if HDFS client did not start the transaction from name node saying that create a metadata, it's like booking a slot, meaning if somebody else is coming to write the same file, it will be rejected by the name node. Okay, why? Because the same, say you are trying to create abc.txt, you are trying to upload abc.avi, or let's say abc.txt for time being. Now somebody else comes while you are still writing abc.txt to one of the data nodes, name node will reject that write. Why? Because it's being written by somebody else, right? So no two persons will be able to write the same file, right? So therefore this the transaction starts with name node. Okay, it's just like transaction. It's a two-phase commit. So transaction starts from name node, and after that we move on to data node. And once we finish with the data node, we again go back to name node and say it's finished. It's no longer dirty. All right. So this makes it. That is the reason this whole transaction works. Okay. Is it clear now? Yesterday there were some questions regarding synchronization, regarding dirty reads, dirty writes. Why required third data node in pipeline? That's a good question, then, Kumar. The problem is that we want three replication factor. So client will be writing to one while the block is being copied between data node 1 to data node 2. All right. All right. That's a very good point. Prashant is saying, can you please talk about rack awareness? I'll talk about rack awareness when we are towards the end of map reduce discussion. Okay. Then the rack awareness will make a lot of sense to you. Does it update name node after all the replication is done? Yes, it does update the name node saying we are done with replication, and you can I mean we tell the name node that hey, the replication is finished. Okay, so that name node does not worry about. Otherwise, name node will keep on showing that the replication factor is low. Okay. Also, name node is informed the replication is in process. Name node will reject read request as well as write when file. Yes, yes. So you are writing a file and somebody is trying to read it. Most like it, name node is going to reject it. HDFS client update name node after. So no, it's not HDFS client which updates the name node after replication is done. It is the data node which informs the name node that it is done. It is the individual data node which allows the name node, which informs the name node, as well as each data node also informs the backup name node or secondary name node. All right. So both name node as well as backup name node are informed by each data node. Yes. Name node will okay. Let me go through the questions. I think I've covered. Does it update name node after all? Yes. Okay. All right. All right. Not really, not really. So, okay, so the diagram looks like this. Okay, so this is better diagram. Okay, so client writes one block here, one block there. They both are replicated to each other. All right. So the dynamics, which one is going to replicate to which one, is decided by name node based on the availability of individual data node. Okay, and how does okay let me just okay let me make the window bigger. All right, let me just copy this. Okay, All right, so I think this is better too. Okay, all right, good, good, good. We have got so many good questions today. I'm pretty happy. All right, so how first data node will write to other data node? Suppose name node writes like 234, here 3 and 4 replicas, but data node 2 come to know like need to write to in 3 or 4. Okay, okay, yeah. So name node, okay, name node knows what is where, which data node is free and which one is full. Okay, and accordingly name node informs the data node to create the replication accordingly. All right, so that is how it works. The diagram shows that data node 1 writes to data node 2 and data node 2 writes to data node 3. How are data nodes aware of each other? So data nodes are mostly dumb, they are not much aware of each other. The person who is making the making them talk is name node knows which data node is free, which one is busy, and which one is far and which one is closer, and accordingly informs the data node to start copying data from one another. Okay, how does name node and data node communicates any signals? So basically they communicates via normal TCP/IP protocols. All right, normal TCP/IP protocol. And in a secure environment, they communicate over SSH. Okay, so if okay, good question, very good question. So if while writing data to the data node, if any one data node fails, then how the client will inform name node? Okay, so basically at any point of time, at any point of time, say if a data node goes down for some reason or anything happens, name node is informed by the data node. Even when the replication fails, even when one node is unable to replicate because of the storage issues, in those cases, the sorry, name node is informed by the data node that I'm unable to replicate. Okay. Now HDFS will either inform you or it will, you know, HDFS will inform you as an admin that your data unable to replicate because there are disk storage issues, these problems, that problems. And in critical situation where data node is name node or data node or the whole HDFS is not able to abide by its promise, generally the data node shuts down so that you don't read the file which has the low replication node. Okay. Now let me. Who is responsible for concurrent read and write? Very good question. So who is responsible for concurrent read and write? Any guesses? Anybody? Right. Right. So generally the two concurrent reads are allowed. Okay. But r- read and write cannot go hand in hand. The file is being modified, and also the HDFS is mostly like a append only, meaning so when you are trying to change a file and then save it, it does not alter the bytes. It basically creates new block and then make the new blocks part of the file, right? In- Okay, so that also ensures that while one new change is being in place, the existing one is not too much disturbed. Okay, which means if because it is going to create new block, and if this new block, I mean, this new block cannot be read by the people who are reading the existing one. Okay, so this concurrency is very well done with by the name node. Okay, sounds good. All right, all right. So did I miss anybody's question? Okay, so I hope I have answered. How name node get failure if first node right? How name node gets failure if first node. So if there is a first node failure here, while the client is trying to write a block, first copy is written directly by the HDFS client. If HDFS client is not able to write, or name node at that point itself detects that replication is not possible because we do not have space for replication, it will give error then and there to you. All right. And in case even the first block writing fails, in those cases HDFS client is informed immediately that you are not able to write the data, because first copy of the file is going to be written by HDFS client only. Why? Because that's the only one which has the data, right? The second and third copy, or nth copy, whatever number of replication you have, will be mostly between the data node to data node. Okay, and the first copy of the blocks is always on the same node. It is always on the same node from which you are uploading the data. Okay, or on the node which is closest to you, so that when the client has come to write the data on name node, it is immediately finished. You don't have to wait for too much to do that, right? So how do you test all of this dynamics? Try copying a big file such as, say, 5 GB onto the Hadoop. Okay, try copying that. You will notice that this file is being uploaded, and after some time the storage will go up while the replication goes up. All right, and these dynamics, most of these dynamics are configurable. All right, hope. Okay, so did I miss anybody's question? Okay, how name node does name node smart to handle update? Yes, so every update to a file is actually a new file creation. Okay, it's a new file creation and new block, or new set of blocks. Just that it's append only, which means and if you are changing any block, so basically the if you are writing forward only, then it will keep on creating the blocks forward. If you are saying update this file and this is the new content, it is going to delete the old, I mean, it is going to create a new set of blocks, then drop the old blocks and then carry on. Right, all right, now moving on. Very good questions. So this is write and this is read. All right. So HDFS client first in the beginning via distributed file system, it goes to the name node. Okay. DFS distributed file system goes to the name node. And whenever we want to read a file, name node returns you the location of the blocks. Okay. Now every block has got multiple copies, so it returns the location of even the backup copies of each block. In case it's not able to read from the first copy, it will try to read from the second copy, and so on. Okay, that is how this dynamics of reading the data works. Right. And you can clearly see that HDFS client is now directly reading from the data node. This is the remote server on from which it's reading. All right. Now some more information. This anyway we have covered. So metadata is maintained in the memory. The entire metadata is in the main memory. And whenever, so which means that the more number of blocks you have, the more memory name node will consume. Okay. So that is probably one of the design concerns people have, that more number of files, more number of data nodes will lead to bigger memory usage on name node. Okay, but in for practical reasons, name node is actually good enough for handling zettabytes of data. And then types of metadata could be list of files, list of blocks of each file, and list of data node. So name node will be having many files, right? So it will, first of all, there will be too many files, and for each file there would be blocks, and for each block there will be replicas, and all of this information, it will be at the name node, and for each block or each file there will be file attributes such as access time, replication factor, etc. And then there is something called transaction logs. So whenever you make a change or you do something, this is recorded as part of transaction logs, and these transaction logs are in the disk. All right, so let's have a look at other components available as part of the whole ecosystem. So these are the components available as part of the. Okay, so so Karthik, I hope I answered your question. Nasruddin's question is there any limitation on available memory for name node? So name node should have more and more memory as possible. Okay, and I mean this is configurable. So if you, I mean, all of these things are configurable. Now Satyanarayan's question is there any ideal size for the memory for. Okay, just a second, I'm getting few calls. All right, let me just turn off my phone. Good. Yeah, is there any ideal size for the memory of the name node? So as a thumb rule, For even if your cluster is maybe 5 nodes and you're trying to manage 100 GB data, I mean, few terabytes, maybe 10 terabytes data. For those kind of reasons, you generally keep a system which has minimum of 2 to 4 GB RAM for the name node. Okay. Otherwise, I mean, it will be a little difficult to manage with the name node, because name node and other systems will go hand in hand, right? So, so by default, the default configuration itself, name node consumes around 2 GB of RAM, but you can configure it to bring it down to maybe 512 MB. All right. So that was Satya's answer. If name node failures or get restarted, from where the metadata get pulled? Very good question. So all of the memory of name node is always file system supported. So but the first write is into name node's memory, and then that gets pushed to the disk. So anytime if the name node gets restarted, shuts down, or there is an error at name node and we have to put any other system in place, we can do that very easily by, basically, we will be able to restart it, because everything in the memory of name node is actually disk supported, right? Interesting questions. Great. So metadata is pushed to the disk, as well as there are transaction logs, and we can always recover it from there. Now, as part of Hadoop, this is the component diagram of the Hadoop ecosystem. All right. So Hadoop distributed file system is something we discussed. Then there is Flume, there is Scoop. Flume is for unstructured data, import and export of unstructured data from and to Hadoop. And Scoop is for importing the data from your relational databases. What is so big deal about Scoop? First, it provides you the driver for almost all databases. Second, it provides you a distributed way of importing data. You can utilize all of the data nodes to import the data parallelly. Same is the case with Flume. Flume basically makes it possible to distributedly download the data on each node. Say, for example, you have to download the data from Twitter. So you can write the whole thing in Flume and distribute the whole logic to all the data nodes. So all the data nodes will be parallelly trying to talk to Twitter and then download the appropriate data which is required. So that is the kind of magic which Flume Scoop bring in. After that, there is something called Yarn. Yarn is the framework which basically makes it possible to execute any node, any logic on any node. Okay, Yarn takes your logic, distributes it on the data nodes, and gets it done. Now, to utilize Yarn, we have to have some sort of paradigm. Okay, we cannot directly use Yarn because Yarn's role is like an operating system negotiating the resources. Yet another resource negotiator is the full form of Yarn. And now the MapReduce computing engine essentially uses Yarn. Similarly, the newer components such as Spark, they stand on top of Yarn and control Yarn to get their work done across the network. Now there is something called HBase. Okay, so there are questions. I think I should take the question first. What is the difference between semi-structured data and unstructured data? Semi-structured data and structured data, there is a slight differences. First, let me define what is a structured data. In a structured data, you know which byte represent what, okay, and which byte is a part of which data type. So when we look at a relational database table that is the best example of a that's the best example of a structured data, because we know what are the columns, their names. We also know where does the column start at which byte, till which byte it goes, and we know that what is the data type of this data. Okay, whether it's a string, integer, or anything, everything is represented by zeros and ones. That's sort of everybody knows, right? And and if we know that what exactly which field each byte is part of, what is the data type of each byte, then we call that data as structured data. Structured data is ideally in the form of relational database tables, right? Now, semi-structured data, in case of a semi-structured data, we generally have only half information about the data, either only the number of columns, I mean, which byte is part of which field. We only know that, but we don't know the data type of each column. For example, CSV. For example, lot of XML data. In case of lot of XML data, it's sometimes it's just semi-structured. We don't know which part belongs to what. Okay. Unstructured data, we don't know what are the fields in the input. How do we divide the data into each individual operable component, such as rows and columns? We don't know that part in case of unstructured data. Unstructured data is generally considered like an Apache log, where the data is lying in the file. You'll need a parser to convert structured data into, sorry, unstructured data into structured data. So that is the difference between structured, unstructured, and semi-structured. Okay. So in case of a structured, we know data type as well as the columns. In case of a semi-structures, we don't know either. We don't know half of the information, such as the data type of columns, but we know that where our field start and what data is part of that field. While in case of unstructured data, we know neither the fields nor the data types. Now, input data will be splitting into number of inputs and store in the data nodes. Same data store in name node. Input data will be splitting into number of inputs, yes, and stored in data nodes. Yes, same data is stored in name node. Mm, did I miss a question? Okay. So whenever we want to store the data, it will be splitting into number of inputs, and that data is going to get stored in data nodes. So I'm missing the question. Purushottam, will it be possible for you to rephrase it? It'll be great if you could rephrase it for me. All right. Yes, name node just stores the metadata of the data. Yes. Name node doesn't store the actual data. You're right, Prasad. Thank you. And all right. So yarn is something which which basically gets your work done on top of each different machine, while the definition of work and what to execute comes from the programming paradigm. One such thing is MapReduce and other is Spark. Both of them actually utilize yarn, though Spark also runs on multiple other systems. So Spark also runs on multiple other systems and is able to also run on yarn. Now there is something called HBase. When you have millions of columns and by billions of rows, in those circumstances, you would like to use database such as HBase, which has a similar model and also runs on top of HDFS. It's a NoSQL database. Why? Because it's more like a store, not a database actually. And each the whole database is distributed onto multiple computer for the high availability. Now, the next thing which is important is, since HBase is not providing you the query kind of language, it is the Hive which provides you the ability to query the data in HBase. How secondary name node gets its metadata update from name node? That's a very good question. That's a very good question, and this is where lots of people are confused. So, secondary name node or backup name node. Okay, there are two kinds of nodes: secondary name node, backup name node. The objective of both the kind of nodes is identical, meaning providing a backup for the name node. All right, because there are chances that name node could be that way. So for that, there are two kinds of backups strategies given. One is in the form of secondary name node, other is in the form of backup name node. Okay, so secondary name node is basically has the details about the transaction log, plus it has the backup copy of the metadata which is stored onto the file, right? So to bring the secondary name node back to the life, what you need to do is you need to figure the metadata from the disk plus transaction logs, and then you bring it up. But there are that is too cumbersome for the sysadmin, okay, to get it done quickly in case of a disaster, right? He has to rummage around, find where is our metadata, where our transaction log, we have to apply this, we have to apply that. So it will take a lot of time for the sysadmin. So couple of engineers actually build something called backup name node. Now backup name node is an interesting idea in which name node, anything which is being written to the name node is also sent parallelly to the backup name node. Okay, so any update that I'm done with the replication, this is the I'm busy, all of the information which is there in the name node is also available in the backup name node. And this is done because each of the data node keep on informing both the servers, name node as well as backup name node. It's not only the name node which is copying its data to the backup name node, it's also each individual node which is informing backup name node parallelly. Is there restrictions on metadata which are not allowed to store, like soft links etc? No, actually soft link is not a metadata. Metadata can be anything which has file name and other stuff. Okay. If you are trying to upload a soft link, a file which has a soft link, it will basically copy the whole data onto your HDFS. You can try this out. Recovery is very easy from the backup name node. If you have a backup name node, you can quickly swap the two, while secondary name node requires a little bit of expert person to bring back the node. Yes. So do you mean to say that data node talk to backup name node directly, or is it a master slave? So yes. So the way data node informs name node Data node also informs to the backup name node, and data node keeps informing both name node as well as backup name node. All right, because the overall idea is to keep the name node free as much as possible, because name node is singular. If we keep on delegating everything unnecessarily to a name node, it will die of overload. Therefore, even the backup requests, I mean, anytime we are changing name node, we are also changing backup name node. Good. All right. So Chetra's question is little big. Let me read it out. As all ETL tools are expensive, we want to move into big data and want to use data warehousing concepts, facts, and dimensions to make a decision on report. Is it possible using Hadoop? If so, then what are the components we have to work on it to make a data model and EDW reports to do the analysis? It is definitely possible, but probably you will have to take the support of HBase. Okay, so the most closed system, I mean, most closed system to your data warehousing, how DDW, EDW is your HBase, and HBase provides you the column and rows kind of structure. Now, but the problem is HBase does not support more than one indexes at a time. Okay, there's only one index called keys, and the other is on the column name. Okay, so you will understand once you go through the HBase section, you will understand that most of your work, which you are overloading your EDW, can be delegated to HBase. All right, things are definitely possible, but you will not be replacing the whole EDW just like that. You will be basically forking some of your data, I mean, taking some of your data to HBase, you know which is too much to handle in EDW. So while replacing backup node in place of failure name node in that particular time, failure name node in that particular time is the, yes, definitely there is a possibility of data loss. Why? Say a person was writing to the name node, so it's informed the name node that, hey, I am writing the data to the backup to your data nodes. So it starts the step number 2, remember, in the file, right? So it wrote this information into the name node, and it went off to write the data to data node. Now what will happen is, in the meantime, while it was writing to the data node and it was about to finish from the data node, or it may have finished from the data node, the name node went down. Before it could commit, before it could say that I am done, the name node went down, right? Which means that whatever work this person has done, this client has done to store the file onto the data node is actually lost, because those blocks will be overwritten in the next pass, because those blocks are not considered as part of the file system. Okay, because they are not committed yet. Had client been successful at informing name node that I am done writing these blocks, this could have been great. But before it could commit, before it could go back to the name node went down for whatever reasons, and it could not inform the name node, and hence the file will be rejected. And SDFS client who is trying to write the data will get an error saying unable to write the data. All right. Okay. So if both name node gets failure, then do secondary name node give the backup to the name node's metadata? You mean to say both name node and backup name node fails? That's what you mean, Pavan? Okay. Yeah. So this is a really, really paranoid approach. And question is that you have got name node, you have got backup name node. What if the backup name node and name node both gets corrupted, both hard disk goes, both has to shut down? What will you do in those cases? So in those cases, you generally take the metadata and take this metadata and give it to a new node, and try to recover this data by booting a new name node. Okay, because metadata is available in the disk, as well as you have the transaction log. So you will apply transaction logs onto the data. Transaction logs you will apply onto the metadata, and then you bring it back to life. Does HDFS client So question is, does HDFS request writes file to name node and backup name node, or only the name node? So it's both. So uh, basically, when the HDFS client directly comes to the name node and tries to write the metadata, name node copies the data to the backup name node. Okay. Similarly, when HDFS client is writing the data to each of the data nodes inform both name node and backup name node. Right? How can we configure number of backups for name node as well? So for name node, you can only have at most one backup, right? Because that's the part of protocol. You can at most have one backup, because each data node is designed to inform only two nodes. One is name node, other is backup name node. All right. Now, getting back to what is federation means. Federation, very good point. Let me explain. Before, lot of lot of times you will see federation here and there being used. Federation means absolutely delegating things to a separate unit or to a subunit, instead of one single node being being everything. Okay. Federation you delegate things. For example, DNS name lookup. Okay. Or say mail exchange server. Any message you send from Facebook to another person, it goes via Facebook, and the other person has to have an account at Facebook. That is the exact opposite of federation. Now, what does federation means? That ITC Infotech is able to have its own. ITC Infotech is able to have its own mail server. Okay, and everybody is able to basically have their own email server. So when I want to send email to somebody who is working at ITC, what will I do is I will directly find out what is the IP address of ITC mail exchange server, and will deliver the mail directly to ITC, instead of talking to Facebook and storing it at Facebook and asking users of ITC to log into Facebook and check the mail, right? So email servers are federated model, in which everybody owns their data, everybody takes care of their own system. So while things like Facebook are not really a federated model, okay, are not really a federated model. All the users, they have to have their all information is stored in Facebook servers. Okay, it's not like that some of the users are having their accounts in our infrastructure, some are having somewhere else. So that kind of model is no longer there. Okay, so that is called federation server. If name node goes down, then we get the data from metadata, backup data. So then what is the use of secondary name node? So yeah, that very good point again. So if name node goes down, we get the data from backup name data from the disk, right? We have metadata, and we have, you know, transaction logs. We can apply transaction logs onto the metadata, and can deduce that this was the data, right? Now, the problem with this approach is it takes too much time to bring back your HDFS to life. Okay, it all depends on how it will require a manual intervention. It was a bad design, not bad design. It was an old design in which name node goes down. The possibility of name node going down was low, but was very slow process because it requires too much of manual intervention. Instead, instead, then in the new design, what was done is we built this logic into the name node, sorry, data node itself, to update the keep updating both name node as well as backup name node. That was a that was a newer design. So that's the purpose. Okay, secondary name node is essentially copy of the metadata, but again you will have to apply the transaction logs. But backup name node, you generally have the all the information pushed by the data node onto the backup name node, whatever is there in the name node. Okay, all right. So we were talking about Hive. Hive provides you the SQL interface to HBase and others, HDFS. While similar to Hive, Hive is a SQL query language, and anything you write in Hive is going to get converted into MapReduce and going to get executed on Yarn to get the results. Okay, so so whenever we do some sort of operation in Hive, say we want to read some data, or we want to say do a group by, do sorting, do searching, everything gets converted into MapReduce. And MapReduce means it will get divided onto multiple computers, and your work will be done, and then you'll get the results. Okay, so any computation we generally do on these devices, it has to be done on all the nodes instead of only few nodes. We'll talk about this in detail. Okay, but you can understand for now is Hive is a SQL interface to your HBase as well as HDFS. If you put a CSV file onto HDFS, you can do a churning of the data using Hive as well as Pig Latin. Pig Latin is almost like Hive, just that as a language, it has been designed bottom up for catering to big data plus semi-structured data. Okay, for Hive you have to define each and every column. For Pig you don't have to define it. You will understand it when we talk about it, but for time being you can understand that this way, that whenever you have to query the big data, you either use Hive or you use Pig Latin. All right. It's moving. All right, good. So Pig Latin is also a beautiful language. It's a similar to SQL, just very simplified version of SQL. In SQL you write all the queries into single shot. Okay, while in Pig you keep on defining subsets just like views. Okay, and Pig is also far more efficient and provides you many tools to control the execution style. Now the most important part of the game is Mahat. Mahat is like a magician in the game, because Mahat provides you almost every algorithm you require for machine learning or statistical analysis. Mahat provides you both machine learning as well as statistical analysis. Okay, so basically, without it's not a programming language. Okay, Mahat is not a programming language. Mahat is a library in Java. Okay, it's a Java library which automatically executes its logic onto the whole Hadoop cluster. Okay. Hi, is my voice breaking for all? Hello. Okay, so it's breaking. Let me try to see what exactly. Hello. Okay. Okay. All right. So is it clear now? Okay. Okay. Better. Better. All right. Good. Good. So so out of all, the Mahat is somebody who basically provides you a brilliant library, and for your surprise, the whole recommendation engine which I wrote, it the actual recommendation generation took me hardly 15 minutes. Okay, my 95% of the work was plumbing the data, churning the data, importing the data from here to there, cleaning it up, and then converting the data into the format in which Mahat will accept took me took took away my 95% of the time. While doing the actual work, generating recommendation, okay, took it didn't took much of my time. Didn't take much of my time because Mahat provided very straightforward way of manipulating data. Okay, so all Mahat wanted is say three columns: user ID, product ID, and how much this user likes this product. That's all. And based on this, it provided gave the recommendation. That so it was very straightforward to begin with, but when it came a challenge of tying all the things, all the components together, because I had to pull the data from my Apache servers and then bring all the data onto a central place, clean it up, say I don't want the data for US, only I want for India, then those kind of cleaning, then preparing the statistics, how much the user wants, how much the user likes a product. That was done in MapReduce, and then once that was done, we generated the recommendation using Mahat. And since there were multiple things which were running parallelly, importing data, changing the data from one form to another, then executing custom Java code to clean it up, all of this was tied together using Uzi. Uzi is like your ant, or what is it, what is the build system you guys use? What is the build system do you use? Do you use make MVN? Good. So you can think of Uzi like a MVN or ant, so that so that uh, I mean Uzi basically makes it possible to write the XML saying once the import of Flume is done, then start the MapReduce. And once the MapReduce is done, then do this. Send an email to somebody. So all of this tying together, this workflow part is taken care by Uzi. Okay. Uzi, I mean, you might have to push data from local file system to SDFS, or you might have to do a lot of things. All of that is done beautifully using Oozie. Oozie has a server as well as client. All right. So while Pig does not have the server, so we'll go into the details of each of these components over a period of time. All right. So this we have seen yesterday. Let me again go through the cloud. So let me just give you guys also the URL. Try it again. Okay. Now this URL, are you guys able to access it, or are you getting a security problem? So password I will not be speaking here, because this video might, you might share this video with other people. Okay. Therefore, I'll not be sharing the password. Okay. Okay. So you are still getting the security problem. All right. So maybe you have to work with systems to get it resolved, or let them suggest me a way. Let them suggest me a way, or you can connect us to the systems so that we can also inform them, raise a ticket, and we will basically, there should not be any violation of anything when we're talking about this kind of environment. And also note that there is something called here, there's a file browser. Do not upload any private data over here. Okay, it's mainly a playground for everybody. All right. And when you're working on it, please create your own folder. Okay, please create your own folder before you start working. All right. So this is the HDFS file system where you can upload the data. And here, this is the job browser where you can see what are the jobs getting executed. And this is our Oozie job designer, where you can define that what jobs you want to create. And here you can see the pig in basically you can execute your pig query using here. And right, and then you have hive. Okay, you can execute your hive queries here. Already people have see you using it. All right, so this is how you interact with the each services. While there is something called 8080. So this is the admin control panel, from where you can install you can move services around the cluster. Okay, you can move services around the cluster. Now see, Oozie is not running, for example. So this is okay, this we have shut down knowingly. While Oozie server is not working, so we can turn on the Oozie server from here. All right. All right. Other than this, if you are a little uh, a little bit more entrepreneur and enterprising, then what you can do is you can download the virtual machine as mentioned in the doc. Okay, and start working on that. Okay, but that's not required. Okay, that's not required. All right. So although you can actually download the virtual machine as well as you can work here. Okay, it's completely up to you and it's your own call. But I would recommend that you continue with the cloud labs, because that doesn't build a mental block of starting a virtual machine. Why? Because virtual machine takes up your RAM and makes your computer a little bit slow. Also, sometimes your computer might not have enough RAM and you may not like to start. the virtual machine. So and that is why I strongly suggest that you continue with the cloud labs. All right. All right. Now Uzi is up, as you can see. This is admin, the control panel. Now, if you there is another third way of accessing our cloud labs, which is SSH. SSH is the real way. If you are not very handy with Unix, you should learn the basic commands. Okay, you should learn the basic command of the Unix. And for Windows people, you can use SSH, WinSSH. There are PuTTY. You must be knowing about PuTTY. So you can use PuTTY to the way I'm doing SSH Hadoop one dot nobigdata.com. Before that, you can put student at Hadoop one. So it'll ask me a password. The password is mentioned in the doc given the session 1 LMS page. All right. So now I am logged in from my local machine. I have reached to Hadoop one server. I can see what are the processes running on this machine by using PS. I can see what the file system, and I can create whatever folder I want to do. Okay. And there are three things to remember. There is your local machine. Okay. In my case, it is Mac. In your case, it might be Windows or it might be Ubuntu or whatever. And then second one is the Hadoop one's local file system. And third one is HDFS file system. So when I do ls, it is the local file system of this file, this Hadoop one dot no big data. But if I say Hadoop fs minus ls, then it shows me the output from the HDFS. This is my HDFS. You can compare this. We have widgets dash old, and here also 8000. Here also you will see widgets dash old. Okay, Karthik's point is that the Google docs are not accessible. We have to, okay, we'll make sure that we convert it into text file. I'll make a note of it. Okay. All right. Now you can see in the same file system which you see from Hadoop FSLS, it's the same file system here. You see Venkat with the widgets old. Here also you can see Venkat with the widgets old. Perfect. All right. Now that those were the admin console we talk about, SSH we talked about, and then Hue. Similarly, you can see Hadoop FS, and if you just enter, it'll show you all the commands available as part of Hadoop client. When we said Hadoop client, which talks to name node, data node, this command is the one who does the job. Okay, so there are multiple commands as part of FS. Hadoop file system is, you can see, starts with append to the file. Cat is for printing file. Checksum, it shows you the checksum of each file. Okay, MD5 checksum. Then change group, just like you have in Windows, you can change, add user, change the group of the file. You can do that also. You can change the mode, the permissions on a particular file, as well as you can change the owner of a file. Okay, and to upload the file from local file system, you can use copy from local. Okay, so this will basically copy from my Hadoop server. Okay, so if you want to go through this route of uploading file to HDFS from your desktop, you will have to go through the two steps. First, you will have to copy the file to Hadoop one, and then you have to upload that file onto the server. So somebody is not muted. All right. So copy from local basically copies the data from Hadoop 1 to Hadoop. All right. And copy to local brings down the data from HDFS to this. But instead of going two steps, you can actually upload data directly here. Okay. You go into a folder, say widgets old, and then you can simply upload. Okay. You can upload a file, or you can upload a zip file which will be extracted by itself. Okay, you can click on upload, select the file. So from your desktop, you can directly upload to HDFS using this browser interface. Okay. But good news is that copying data from Hadoop local to the data node is very, very fast, because the data copy just from the same file system to same file system, because the first copy of the data is on the data node which is on the same machine. All right. So is it clear to all of you? You have tail, you have all of these commands. You can rename the file by mv, and you can do the ls, you can, and you can basically change the change the various kinds of parameters of a file. Okay. Here, set replication basically changes, replica factor changes the replication factor. Okay. If you are seeing that this file is taking too much of space, and it's too big a file, then you can change its replication factor from 3 to 1 or something like that. All right. So, and moreover, you can have a look at fs minus help, right? So basically it'll give you the detailed help on what each function does it, right? And all right, expunge, exactly what it does should be here. I haven't used expunge. Empty the tray. Yeah. So what happens is when you are trying anything, right here, if you're trying to delete from Hadoop RM, so the file is moved to the trash. Okay, it's not just deleted. Just like on Windows, expunge will basically clear the recycle bin or trash. Okay. Try doing Hadoop RM on your file. It will tell you that it is moving it to trash. Okay. All right. So do you have any questions to me? I'll give you a minute, and then just give me a second. Okay, so how long the deleted file how long the deleted file will be in the trash? The file is my audio available now? Okay, okay, okay. So it will move to HDFS trash and it will be lying there. Okay. And exact dynamics, I don't know. I don't even know the exact dynamics of the Windows trash. Okay. Yeah. So exact dynamics as in for how long will it be lying there? That and what is the upper size limit of the trash and so on. Okay. That is something I don't know. All right. So okay. So you can use this command. We'll go into some more examples. Okay. Now let's start with the session for what we had planned for today. So we had a great set of questions today. All right. This we have. Okay. So today we are going to start something called compute engine. Okay. Hadoop initially comprised of two parts. First one is the file system, other is the compute engine. Here specifically Yarn. Yarn is the yet another resource negotiator. And instead of getting into the complexity of Yarn right away, we will basically try to simplify the model and we will first understand the simple model. Okay? We'll first understand the simplistic model of Yarn and then we'll move ahead. All right? Okay. So this exercise is going to be little more aggressive. So my question is, before we understand why do we need a compute engine, let me ask you, how fast can 1 gigahertz processor sort 1 terabyte data? How fast can a 1 gigahertz processor sort 1 terabyte data? What does it mean by sorting? Sorting means ordering the data. Imagine you have got 1 terabyte of strings, 1 terabyte of name of things, people, or some random strings. Some imagine that you have 10 billion names having 100 characters each. Now you want to order this data, right? You want to order this data. Now, how much time do you think your computer will take? You've got an average computer, like you've got 1 gigahertz processor, RAM is 2 GB. Now, how much time do you think it is going to take? All right. So why this question? Because sorting is a very important phenomena, and Hadoop, the MapReduce engine, is nothing but a grand sorting engine. It's a it's a Mughal version of sorting. Okay, it's a Mughal version of sorting. So that is why I'm asking you a simple question. So we all have done sorting when we use our Excel sheet. We just select the data and say sort by this column, right? Order by this column. Similarly, if your Excel sheet keeps on growing big such that it has 10 billion rows and you want to sort that data, how much time do you think it is going to take? First answer would be that it will depend on the software, right? But every software is going to use probably let's imagine that they all are using the most efficient software and most efficient algorithm for sorting takes how much time? Can somebody tell me what is the complexity of the most efficient algorithm for sorting the data? sorting as a problem, the ordering of cards, ordering of the data, ordering of books, ordering of anything is essentially a age old problem. Far, far, far before then, the computer, we had the sorting problems. Okay. So, yes, thank you, Prashant. So, in the best case scenario, the total number of the total time consumed by any sorting is proportional to number of items into logarithm of number of items. Okay. So if you have got n number of items, so n log n is going to be the time. I mean, the time proportional to n log n is going to be consumed in sorting. All right. So if sorting of one sorting of two records takes 1 second, because sorting of one record does not mean anything. Sorting of two records takes 1 second. So how much time will it take for sorting 10 billion records? So just give me a random number. Just give me the number. Here I'm not asking how will you sort. All I'm asking is what does your gut instinct says? What does your gut instinct says about the time which it will take to order this kind of data? Sanket says 5 days. Okay. Anybody else? So even if you are 10 times wrong, or say even if you are 5 times wrong, it's completely okay. All right. I'm ready to accept a 5x kind of error. So few days. Okay. That is Sanket. Anybody else? More than 5 hours. Okay. More than 10 hours. Okay. More than a day. Okay. Okay. 10 hours. Okay. All right. All right, that is good. So for me, it took around 5 hours of 1 gigahertz processor by using really, really sophisticated techniques. And it is beyond the, it's not possible to basically go it beyond 5 hours as per my expectation. All right. So this number 5 hours essentially shows that it takes time to sort the data. When we create an index on a table, we always expected that index would finish in maybe half a second or maybe 1 second. But if the data is in terabytes, it might take days or it might take hours. All right. Now, so as you can see that 5 hours is probably the best time you can have on a desktop to to sort 1 terabyte of data, and with more sophisticated algorithms. If there is a slight leak or slight problem in the algorithm, this 5 hours can suddenly become the 15 hours. Okay. Now, so what is wrong with 5 hours? We might need a faster sort. We need we need to get this thing done less than 5 hours. The kind of requirement we all have, we cannot wait for 5 hours. Our user cannot keep waiting for 5 hours. Second, we might have to sort bigger data. So if we have 2 terabyte data, how much time do you think it is going to take? If Sorting 1 terabyte data takes 5 hours. Can anybody tell me, will it be less than 10 hours, more than 10 hours, or equal to 10 hours? Anybody? More than 10 hours. More than 10 hours. Good, good. So I did not use a formula. The problem is my formula said that it will take 1 hour. Okay. But when I actually did, it took slightly more than 5 hours. Why? Because it was not only my estimation of n log n, it was the most of my CPU's time went into reading and writing data from the disk. Reading or writing the data from the disk. Most of the time went into that. Okay. Therefore, it was impossible to actually compute. It is actually impossible to actually compute where do these 5 hours come from, because there are so many factors. First is read write speed of my SSD. Also note that I did it. I did it using three auxiliary SSD solid state hard drives. Right? Is the voice not there? Satyanarayan cannot hear me. Okay. All right. So, and we need to do it more often. Other than we need faster sorting, and we might have to sort bigger data. We might have to do it more often. Okay. So that is why we need a compute engine. We can do it faster, which can sort bigger data, and we even if we have to do it more often, we should not have any problem of plumbing the data, plumbing here and there. And that is the reason, and just to solve this kind of problem, Google came up with the whole MapReduce engine, where they were able to sort 10 petabyte of data. And how much is 1 petabyte? 1 petabyte is 1024 terabytes. Okay, which means 10,000 times data they were able to sort in 6.5 hours using 8,000 computers. This is probably the best record of 2011 so far. And also note that sorting is a problem where there is always some scope of doing things. And sorting as an algorithm is used in more things than you can even imagine. The whole SQL engine is actually a sorting. It has this main job of SQL engine is sorting. For example, when you look up an index is nothing but a sorted data. Okay, looking up in a sorting data is simple problem of jumping into extreme and then middle and then middle and then middle, and you keep on going. So so when it, to look up something in a sorted data is quite fast. Okay, if you have n records, you can keep on jumping into half of it, and you can reach to a particular one. Bisection method we call it, or binary search we call it in algorithm terms. So every index lookup is some sort of bisection method. We keep on jumping in the sorted data, and indexing on a database table is essentially sorting the data. All right. So where clause, whenever we are putting where clause and we are looking up index, it's basically searching in the sorted data. Okay. First significance of sorting. Second significance of sorting is order by in SQL, which is of course straightforward sort. Third significance of sorting is your group by. Group by is nothing but sort the data by the column on which we are trying to group by, and then when there are continuously same items, we group them together. All right. So the group by is essentially a sorting problem. Now third is joining two tables. When we join two tables, we basically sort the column on which we are trying to join the tables, and then we do sort of, uh, uh, similar to we keep on going into both the tables simultaneously from top to bottom, and keep on saying, oh, are these equal, are these equal, are these equal, and so on, right? So joining essentially is also a sorting problem. Joining essentially is a sorting problem. So joining, grouping, order by, indexing, all of those things are essentially sorting problem. And therefore, everybody wants to solve that problem. So Google solved the problem of sorting by using MapReduce, and then people like Hive or Pig, they built whole SQL around this MapReduce engine. Okay. So hope the concept is clear. I'm trying to drive the point. Oh, okay. I think we were supposed to take a break. Let's take a break for 10 minutes now. All right. Let's take a break of 350 till 350. All right. Break for 10 minutes. 10 minutes and back by 351. All right, I'm back now. Are you guys back? Should we start? Should we start? Great, great. So let's start now. And yeah, so we talked about two things. First, why the sorting is so important, and second, why sorting is sorting is a problem when it comes to a single machine, and probably the only way to make the sorting faster is by dividing the work onto multiple computers. We also talked about one point where maximum time actually goes into reading and writing the data from the disk. Okay, most of the time is consumed in this. So all of these points are basically covered in MapReduce implementation. Okay, we'll talk about all of these three four points. First, sorting is a very important thing. Di- Being able to do the sorting on multiple machine is the only way forward. Therefore, the MapReduce was invented, and just like the way we have data node, we have we basically divides our work on two data nodes. Okay, and since the data is located on data nodes itself, so reading writing the data is not a too big a problem, while the disk read write is still slow. But you need to understand that you got multiple hard disks which are reading the data parallelly. Also, there is no need to read the data from the network. All right, so now, earlier we talked about the HDFS cluster, admin node, data node. Similar to that, we have job tracker, task tracker. Okay. Similar to that, we have MapReduce engine. MapReduce engine is actually comprised of job tracker and task trackers. There are single job tracker. The job tracker takes care of the single node. Job tracker is the one which has which is singular. Job tracker is only single, while there are many task trackers. So job tracker does not do much. Okay, all job tracker does is it is like a supervisor of a job shop floor where there are many workers and there is a supervisor. Supervisor's role is to respond to the external agencies that how much the work is done, or how much what is the load currently. So, and also monitor if a task tracker is performing or not. In case a task tracker is down, it will switch the work to some other task tracker. Okay, so it is exactly that shop for so it's just like a workshop where there are too many workers and there is a supervisor. Supervisor monitors the work while the people work. In the similar fashion, task trackers job is to do the work. The work can be of any form. Just like we have a program is essentially a work. Program reads the data from somewhere, does some computation, and and then takes it forward. So so task tracker basically execute various set of instructions. Okay, and these task tracker again, just like we talked about data node and admin node, just like them, Task tracker and job tracker are also network processes. Network processes basically run on a particular port. So task tracker is a process which is running in the background, listening on a particular port. Similarly, job tracker is a service which is running in the background, listening on a particular port. Whenever you have to get some work done by this job tracker, you connect to that particular port, hand over your instructions, and job tracker will find which task trackers are closer to the data you want to process, and it will basically ask those task trackers to get your work done. Okay, so we moved one step forward where we said that job tracker essentially accept one more information which is called file to process. Okay, so whenever we ask job tracker, we also tell him that this is the file which we are trying to process. So it will only engage those task tracker which are located very closely on, to this data which we are asking, and this data which we are specifying to job tracker saying please process this data. This data is on HDFS. Okay, which means the data is located as blocks onto each data node, and each block will be read by the task tracker, and work will be done. All right, now I've got few questions. One task tracker belongs to one data node only, so that's a good question. So not really, not really. Okay, so it is up to you whether you want to run task tracker and data node on the same machine or different machine, or you want to have more task tracker and less data nodes. It is absolutely up to you. It's absolutely up to you, right? But as a thumb rule, you generally have equal number of data node and task. I mean, as a thumb rule, you generally keep task trackers and data nodes on the same machine. Yeah. So default one is basically whenever you are configuring data node, you also run the task tracker in the background, and the admin node also contains job tracker. Okay. So as a thumb rule, we generally have this kind of thing. Okay, so this job tracker is a smart guy. This job tracker basically knows about name nodes as well as data nodes as well as task trackers. Okay, and based on all of this information, job tracker basically takes a call which all task trackers need to be ordered to get the work done. All right, now the other way you can look at it this way. So client asks something to job tracker assigns task tracker the work, and once those task trackers are done, they give feedback to the job tracker. In case a task tracker is dead and is not responding to the ping, the output from task tracker is no longer expected, and the same unit of work is sent to another task tracker. All right, is this clear? I'm sure everybody will be having this clarity because this is how our organizations work. All right. So now, so this diagram essentially takes the user, copies the input file onto. I mean, in this diagram, I'll just go into step by step process of executing something. So when you want to execute or do something, you first copy your data onto Hadoop distributed file system. Okay. And once that data is copied, the second step in the game is we submit the job. Job definition contains what is my executable, what is the entry point, and which file we are talking about. So we give these instructions to Hadoop client, the client we talked about, Hadoop FS. Similarly, we can say Hadoop jar. So user asks Hadoop client to execute a particular job. Once Hadoop client receives it, Hadoop client talks to the file system and finds where all this particular file which the user has asked me, you whatever user has asked the user will client will try to find out what are those input files. Okay, and then the Hadoop client will basically submit it to the job tracker. And job tracker, all right, if the task tracker is busy with some other task, does the job? Yes, exactly. Thank you, Prashant, to bring in that point. In case a task tracker is busy, say our file was located on task data node 1, data node 2, data node 3, and there are three more nodes containing copies of the blocks which are on this one. Okay, so the backup copies of each of these blocks is maybe on data node 4, 5, 6, right? And when we wanted to execute the data node 1, the task tracker running on the data node 1 is extremely busy. It doesn't have the time. Now what would you do? It will basically, instead of using data node 1, it will use data node 4 containing the copy of the block 1 which was there on the first node, data node 1, right? So that is another benefit of having replica other than having a backup. This is the another benefit of having the replica, making the data available to more user concurrently. Okay. Now, if the task tracker fails, job tracker will assign the task to other task tracker available to do from the beginning. Yes. So whatever the first task tracker must be doing or must have done will be completely ignored, because all the output from the task tracker is now ignored from the beginning, as in the whole work which was given to the first task tracker, who went who went down, the whole work will be handed over to somebody else who will do the job. Okay, make sense to you? All right. Now these things will get more and more clear when we talk about it in the detail. Now, job tracker, the next step of the job tracker is to initialize the job. It creates something like a queue. If you have been to any workshop, there is a job shop queue in which everybody puts a number saying this is the job number, this is the job number in the process, and so on. And when the individual who is assigned to the job finishes it, picks up that paper which was put in the job queue, and puts the output next to it. Okay, so basically everybody is doing the job. Once they are done, they put back their work into job queue. Okay, in case once all the elements have finished their work, the whole job queue will be done, and the uh, output will be given to the user, or the user will be informed that the output is ready. The output is stored into HDFS when it comes to MapReduce kind of a work. All right. Now, once initialization of job is done, job tracker will divide the work into something called maps and reduces. And maps are done on the machine which contains the block, transforming block into another form. That is the role of a map. And once the processing of all the blocks have happened, merging of those blocks happen in the reduces. Okay, merging of all those transformed blocks happen via reduces. We'll talk about this in detail, so nothing to worry on this front. Specifically in terms of map reduces, you don't have to worry about it. All right, the blocks are not consumed by maps as such. right? Because as we talked about, the HDFS is heavily ruthless, meaning whether your file is CSV or tab separated or whatever format it is, HDFS will cut the file exactly at 128th MB. Okay, maybe half of the byte, half of the byte is on the, even if it's cutting the data on the half of the byte. Okay, so HDFS is ruthless, and which effectively means the whole block is not consumable, because you say your logic is counting lines and half of the lines is on one block, half of the lines is in another. Therefore, on top of blocks, we need to create something called input split, which can be consumed. All right, we'll go into the details of an input split later on, don't worry. Okay, so some of the items I will be repeating. All right, and but that does not mean that you don't ask a question. Okay, I don't mean to say that don't ask a question because I will be repeating. No, only I mean to say that, uh, I, I mean I will be repeating some of the things. So so I mean, do not worry too much, but ask questions. Big data divided into number of blocks, does it mean input splits equal to? Not really. So input split is a symbolic, input split is a different kind of a, data set, which is more like a logical data set which you require for processing. Say for example, when we deal with plain text file or CSV file, we always talk about line by line processing or comma separated column processing, right? And therefore your logical view input split will have full lines rather than half of lines. Okay, so and for that it might have multiple blocks or it might have a single block, right? Similarly, say your job requires you to have the whole file in a single shot. Say for example, you are dealing with some sort of a binary data processing. Say for example, MD5 hash. We need to compute the hash, we need to compute the signature of the whole file. In those cases, the input split will be the full file instead of a block. Okay, so the input split, a- as a convenience, generally is very to closer to our block size, but it's not necessary. It all depends what are we trying to achieve. Okay, and in case we are flexible, we will tend to keep the size of input split and block very closer, because that would lead to less data shuffling from one block to another, right? That would have least amount of data transfer. Yes, the split is logical representation of block. All right, and this whole split and everything can be customized by writing your own Java classes. All right, all right, great, very great set of questions, and yeah, great. I'm very happy with this. All right, so now we have got. Now let's just get down to map reduce paradigm. We only talked so far about breaking down your problem and getting it executed on multiple machines, breaking down problem and getting it executed on multiple machine. But it's very difficult to break down your problem and get it executed on multiple machine. There has to be some sort of paradigm, some sort of mechanism by which guides us on how to divide our work onto multiple machines, right? And MapReduce is one such paradigm which is really helpful when it comes to dividing the work onto multiple machines. Okay, so MapReduce. So who is not acquainted with MapReduce? Quickly. So are you, who is not acquainted with multiple machine, sorry, who is not acquainted with MapReduce? Some of you must have heard about MapReduce, and some of you must have heard about Google's paper, and so on. You can't hear me? Okay. So yeah, my question is to you: are you acquainted with MapReduce? To all of you, just yes or no. Okay. Okay. All right. All right. So okay. Okay. All right. So we will go into the first. We will talk theoretically. Then we will discuss 4 5 problems comprising of MapReduce. Okay, 4 5 problems that comprise of MapReduce that can be converted into MapReduce, and we will leave the assignment for tomorrow with the MapReduce. All right. Now let's jump in. Okay, so we talked about blocks, and we talked about something called input split, which is logical representation of each block, because the block is sort of a ruthless slicing of the data which may not make sense to us. Half of the word is on one block and rest half is on another, does not make sense to us. Okay, when we process we would require the whole word, we don't require half of the word, or half of the byte is on one, half of the byte is another. That's not something we require. We require the whole byte, right? And exactly for same reason we create something called input split. All right, so now think about this. We have got slices all across data nodes. Okay, now we write two functions, one is called map, other is called reduce. Okay, map and reduce. The map is executed on each of the data, on top of each of the data, or you can say each of the input split is passed through a map function. Map function could be anything. It could be it reads all the data, counts number of lines and prints number of lines in the output. Or map function could be it reverses the input line into something else. Or map function could be it computes the frequency of characters in the input text and gives out the frequencies. So map function could be anything. Or if you think about it, let's say we are talking about some image processing. So if the our input split is an image, we might compute number of red, green, blue components in each of the pixels. That map would be, so map could be anything. Map could be something like image processor. All right, so map is your Java program, or map is your function, map is your command, so which basically takes an input, converts into something else, right? Once that output is prepared, okay, the only thing the map poses, the only mandatory requirements of map is that I need to give out key and values, key and values. Okay, so whenever you are writing your map function, you will read the data from input split, give out the give the output in the form of key values. Now on the basis of this key the data gets sorted, the output of the map will get ordered based on the key specified by map. Map essentially is a function defined by you, and you will be telling that this is my key and this is my data. This is my key, this is my data. All right? And map could be as complex as matrix multiplication. Okay? Now, but for matrix multiplication, you will have different set of mappers and reducers. We will talk about this. If you look at our blog, you can have a look at our blog on our website where we have shown how to do a matrix multiplication using map and reduces. So you write a function called map, which takes the input data, input file, I mean input data provided by the input is split, and you give out key and values, key and values. Now, once you give out these key and values, the data is sorted on the same machine, and same thing is being done on all the task trackers or on all the data nodes across the cluster. Exactly same thing is being done. All the key value being spitted out, the key values given out by the maps is being sorted on each of these machines, and once that is done, all of these key values are sent to a central machine and then merged together. Okay, they all are gathered together. Now you can think of the output to be a big dictionary of key and value, key and values. Key is the word, meaning is the value. So big dictionary of key values is something what is available after merging, and all of these key values are sorted. The whole output is sorted by key. Okay, whole output is sorted by the key. Now once you have done that, you pass the output via your function called reduce. Now this reduce function is given the whole output as the input. Okay, whole key value set is given to the reducer. Okay, now what does it mean by reduce? So for each key there will be multiple values, right? There could be multiple values. So map gave key values, and for each key there might be multiple values split out by different map or same map or whosoever. Now for the input which is given to the reducer is key and values, key and values, all the values for a key together, and the key itself is given to the reduce. Now the job of reducer is to take all of these values and churn them together and give out. Okay, and give out. So that is the main role of map and reduce. So Purushottam, can you hear me my voice now, or is it gone? All right. Now, so Sasikant's question is map and reduce run on different machine? Not necessarily. Okay, not necessarily, because the data, if this reduce is being run on the fourth machine instead of any of these three machines, the data will have to be transferred from these three machines to the fourth machine. Had it been on one of these machines, there will be only two network transfers, right? Only two network transfer. One will be from same machine to same machine. Therefore, who will decide input split? Input split is basically decided by a Java code, which basically takes blocks and converts it into input splits. By default, Hadoop provides you text input reader, which gives you line by line input. Each split is basically a line, single line. And I mean, we'll discuss about input split. Don't worry about it. Here, let's just focus on maps and reduce. You are given certain input. Say, given a line, if you are processing a text, one line will be provided to the map. Now what will map do? Map will take that line and do some sort of processing, form a key value. Yes, so is there a sorting again on the reduce side? That's the thing. Yes, there will be a merge sort kind of mechanism is there. Each of, so imagine this, there are three people, right? Three queues. Sort is when we talk about this line here, you see this one here, the data is anyway sorted. The data is sorted here also, data is sorted here also. When you merge these three data sets, When you merge these three data set, you will have to do a little bit of sort of merge sort, right? Sort of a merge sort, because same key which is outputted by the first map might be there in the second map. Okay, or because these are three, imagine that you are given three queues of people where all the people in each queue are standing in their increasing order of heights. You are standing in front of a battalion of people. There are multiple queues. Imagine three queues in front of you where all the people are standing in increasing order. In each queue, the people who is most closest to you is shortest, and farthest to you is tallest. So you have three such queues. Now you want to make a single queue out of this. That is called merge sort. All right. So all you do is compare the first three, pick up the shortest, and put him in the output. Then pick up the compare the next three and keep on doing it unless you are left with nobody. Okay, so that's a kind of merge sort and shuffle. Yeah, shuffle means we are copying the data from one to another and then merge sorting. All right, let me answer. Does reduce run only after all map jobs done? Exactly, you are correct. Map Once all maps are finished, only then we can form the sorted output, right? Maybe the one which is left comes at the highest in the output, right? Maybe the key is shortest, key is the smallest out of all. Therefore, the reduce is run after all the sorts are done. Okay. As shown in the picture, there are three maps and one reducer. Does it happen there will be always? No. There can be multiple reducers, and the next figure, I will show you examples. Okay, so there can be as many reducers as you want, just that the values for a key values for a particular key all the values for a particular key will be only on one machine. They will not go onto multiple machines. Okay, it can never happen that some of the values for a key went to one machine, some of the values went to another. Okay, that will never happen. All right, now I missed few questions. Let me just go. For all the output there will be. Okay, so I've answered Ramya's question, is it? All right, now. Okay, data is stores in HDFS block, input file 200 MB, then it is stores in two blocks. If 128 completes in middle of any that line. Yes. So yes, Prasant, that's a good point. Prasant's point is that let's say we have 200 MB file. That means they are going to be two blocks. If 128th MB completes in the middle of any input line, that line is included or not? Of course, that is included. That is why when the input split will be created, it will be created properly based on what you demand. An input split is something which you can define that, hey, this is what I want. It's not, it's basically a logical view. You might want to process word by word. Okay. Basically, what do you want to be fed to your mapper is decided by input split. Okay. Input split contains records, just like multiple records mean a data set. Similarly, input split also contain records. Here, when we are processing a text file, if we process a text file, input split is essentially lines, complete lines, no half lines. Okay, input split will have the full lines, and for doing that it might have to transfer the data across other input splits, because blocks do not have complete lines, it might be splitting in between. Now basically the input split is set of records. In case of plain text file, it is number of lines together, and each record, in case of plain text file, each line is fed to the mapper. Okay, each line is passed through the mapper. Now mapper will take the input line, convert something and do something. Okay, if you want to process the whole binary file in a single shot in a mapper, what will you do? You will essentially do a change the change the input split type. You will put something like a binary input splitter. All right, what does spilled record means? Spilled record essentially means that, okay, so that is little advanced thing. So when we are sorting the data, when our map, so from left hand side, input is feeding to the mapper, it's giving the data line by line to the mapper, and mapper is translating the data into some output, right? And that's happening continuously. Okay, and as the output comes in, it is being fed to the memory for sorting, and as soon as the memory gets full, the older records are moved to the disk. That is called spilling. I mean, one block has 1,000 full records and one half, but input is contains, yes, input split can have 1001 lines. So the half record either will move to the first block, or will, sorry, that half line, which was part of the first block, might move to the next input split, or might remain on the first input split. All right, Prashant? It is up to the logic of what is there, what is there in the in the design of your input splitter. No, splits will not cannot be of equal size, because splits have to represent a logical data. Say for example, we want the full line, we don't want half line. If we are counting number of letters in a line, we would want the full line in the record, right? And therefore we would force the we will have the input splitter which returns a full line in a single shot. The default text input reader does that. Or say there is a comma separated file. In a comma separated file, you want all the columns in a single shot. We don't want few columns here, few columns there. Okay, so each row, each line is a row when we talk about CSV reader, right? So that's how it is. So good that we have dealt with this part now rather than later. Good, good, excellent. And the output of the reducer is going to push to the HDFS. Okay, that's a part of the design of MapReduce, while the output of the map is stored locally onto this machine, because this small chunk or the portion of the output is basically useless after it gets merged. So there is no point of pushing it to HDFS, because we don't want to wait, I mean we don't want to have that extra step. It will take more time. In case there is a corruption over here, then the whole work will be delegated to some other mapper. Okay, if this mapper got lost in between or something, the whole work will be shifted to another machine, and uh, and this whole churning will happen again. All right, no, multiple reducers output does not get merged by another reducer. Why? Because I mean, each reducer's output will be stored in HDFS part 0, part 1, part 2, part 3. In case we want to merge it, we can write next set of map reducer and tell it that read all the files in this folder as input. Okay, again, brilliant questions. Excellent. So, all right. Now, again, still we are on the theory part. We will move on to the practical very quickly. Now, so there was something called Hadoop 1 and Hadoop 2. In Hadoop 1, there were HDFS and then there were MapReduce on top of HDFS, which effectively means that anything we have to do, the only thing we can do is MapReduce on top of HDFS. There is nothing else possible. There are many problems which cannot be broken down into key value kind of thing, which was not possible in Hadoop 1.0. And therefore, MapReduce was broken down into two portions, two proper portions. One called the basic version, which behaves like an operating system, is called yarn. Yarn's duty is give me any logic, I will get it executed on multiple machine. Whether it's MapReduce or any other logic, I will get it executed at multiple machines. That is the job of yarn, right? And on top of yarn, multiple kind of systems exist. And this opened up the door of Hadoop to many systems. And that is why, without any changes to Hadoop cluster, you can straight away start using things like Apache Spark and Tej just by using a small library. Okay. Okay. Multiple reducer out will no. Okay. So if we have multiple reducer, so Sasikant's question is that if we have multiple reducers, how do we get a single output from all the reducers? How do we merge? You can just concatenate all the files because output is going to be in the form of key value pairs, right? Because right, so you can just concatenate and you'll get a single one. Because reducer, essentially all reducers are doing, for all the values for a key, they are merging it together. So there's key and value, you can straight away merge all the files so that you get a single file. Okay. Or if you want to do further processing of it, you can write a next set of MapReduce and feed all the files in a single shot to the next MapReduce. Okay. So yeah, so we were talking about the Hadoop 2.0 and Hadoop 1.0. In 1.0, the only computing ability Hadoop has was MapReduce. But after MapReduce was broken down two portions, one paradigm, MapReduce became just one paradigm of computing in form of key value kind of things, and the other portion of MapReduce became the execution of work on all the nodes across. All right. Now, as a consequence of breaking down or modularizing, as a consequence of modularization of this minor step where we broken down MapReduce into two, there has been so many systems which have been coming up every day uh, on top of yarn. Okay, starting with batch processing MapReduce, then Tej, then HBase, then Storm, Giraffe, Spark, HPC, and other kind of systems. All right, sounds good to you? So there are so many systems which were built on top of this. And the only thing is the nomenclature became little complicated, and that is why I have not discussed all the nomenclature. The job tracker and task tracker will became something so many agents. Out of this, what is important to you is one is node manager, which is essentially like a task tracker. Sorry, node manager is like a job tracker to you, job tracker, right? And resource manager, global resource manager is, sorry, the task tracker is basically the node manager, and job tracker is essentially the resource manager. Okay, you can have a look at our cluster. Here we have MapReduce 2. Okay, and now this yarn has something called resource manager. Resource manager is something which is equivalent of job tracker, the supervisor guy whose responsible is which runs only on single node, while node managers are those which run on individual nodes. Okay, and then there are other systems. So these are the two most important component of the yarn. Okay, so essentially yarn was to support the workload other than the MapReduce, its scalability. It was made possible to run multiple kind of systems across the cluster, which means if you are coming up with a new system, say now you want Storm. So for Storm, you don't have to install more computers without Hadoop. You can actually use the Hadoop as is. All you need is you need basically a Storm's client or Tade's client. Don't need to install it. Okay. This is the diagram of Yarn. Yarn has got resource manager. Client asks resource manager to do the job. Resource manager delegates it to node managers. Node managers basically are on each node. Okay. Then each node contains, for each map reduce or any other paradigm, there are application masters which basically coordinate with containers and then do the job. Okay, so basically for internal management it has kept application master and containers. All right, so that is, node managers are on data nodes generally, yes. Application master will basically coordinate between multiple containers and try to get the job done, because when it comes to resource management of each node, what we do is we basically, we might have to transfer data amongst the nodes, and we might have to you know uh, get the application running on multiple nodes. So all of those internal management is done by containers and application masters. Okay, all right, so we have seen the status on the web interface, then we have been able to SSH to the cluster, right? So I would strongly recommend you to use putty on your desktop and try to connect. Okay, and in case nothing is working for you right now, in case you are not able to connect till the IT guys resolve it, you download at least the Hortonworks virtual machine and start working on it. Okay, all right, now, so for putty, when you are connecting, let the port be default, don't change the port. Okay, the SSH port is 22 generally, 23 is for telnet, 21 is for FTP. Okay, and so don't change the port for SSH, let it be. Okay, and that's a default one. So now let's say, so you should actually copy some data onto HDFS, you should all right. Now the name node or resource manager, we call it name node or resource manager, data node or data nodes or data nodes or node managers. Node managers are these. Okay, Hadoop 1, Hadoop 2, Hadoop 3. Sorry, Hadoop 1 is your name node, and Hadoop 2, Hadoop 3, Hadoop 4 are data nodes. Okay, so container is something not I've not prepared those slides. Probably I will need to prepare that one, and we can discuss it in probably the next session or maybe later. Okay, because if we get into more into yarns design, then I mean that then our main thing will suffer. All right, so we'll go into the let me make a note of your question, and probably I will prepare the things whatever is required for container. Okay, and let me see if we can explain it in couple of slides. All right, let me just copy this. Okay, all right, because these are mostly the architectural details of yarn, and if and we it will be better if we basically, you know, and it will get confusing to you also after some time if we get into more into this one, but we'll get into these details maybe tomorrow. All right, I've noted down the questions. All right, are you able to ssh? No, don't put http in front of Hadoop 1. Okay, instead you should be doing, if I had putty I could have shown you. I don't have a putty right now. So all you need to do is we are not logging via http protocol, right? Right, so you try ssh, and then login is a student, and then Hadoop 1 dot no big data. Okay, actually I'm on Mac, so I don't have a putty for Mac, and that is the reason. Okay, hold on. So in putty, all you need to do is in the host, you need to write hadoop1.nobigdata.com. Don't put http colon slash or anything. Okay. Port number 22. Let it be the default SSH one. Don't touch that. Okay. What does it say, Chaitra? What error message do you get? Is it giving any error message for you? And for others? I'm just trying to figure out. Uh, okay, this is good. If you are getting this message permanently added, this Hadoop one to this. Okay. So password of the student is something I'm typing. I'll not be speaking because this video, if you share, will be shared with everybody. So here is the password. All right. Karthik, are you able to reach to the screen where it's asking for password? Yes. No, without http colon slash slash. Sashikant, remove that http colon slash slash. Okay. So the host name is hadoop1.nobigdata.com. What you are typing is URL. Okay. URL is something very specific to Chrome. No, 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 no. This, let me. This. Okay. All right. So if you are on Unix, you can either say this, or you can. Oh, I'm sorry. It's automatically completing HTTP. It's not your fault. All right. It's automatically completing HTTP. It's not your fault. I got it. Okay. So you can also say SSH student at hadoop1.no big data. Connection timeout. If you are getting connection timeout, which effectively means your network admin has blocked on the firewall. So probably by the time these network issues are ironed out, we'll have to you might have to try out the virtual machine. And in the meantime, can somebody I also will talk to the L&D guys and get all of this rectified. Okay, at least our servers hadoop1.nobigdata.com need to be made, uh, you know need to be added into your firewall. Otherwise it will be a big problem in learning. Yeah, everybody is having the same problem. Don't worry. So can somebody put me in touch with the sysadmin or somebody who is handling this? Just give him my phone number. Okay. So if you're opening a ticket, just put him in touch with me. And my email id is sandeep at nobigdata.com. Okay. So just okay. In the meantime, I'll also talk to them. This is going to be a very big issue if you are not going to, you're not able to use it. The okay, because I'm not sure virtual machine installation will be allowed on the machines or not. Oh, great. If for Sashikant is asking password, can you enter the password I've told already in the chat? Password is starts with C, capital C. Did you get the password, Sashikant? All right. No, no, enter the password correctly. I think the error you're getting permission denied is because of the wrong password. Okay. Or Sasikant, can you coordinate with me? I'll have a look at your screen after the session, and then we'll try to do that. Okay. We'll do a go to meeting separately, and then we'll have a look at your screen. Okay. Once if it works for one of you, then for rest of you it will also work. Okay. Let me also have a look at it. All right. Now, all right. So good. So this is something if you are on Windows, okay, use putty. Okay. Host is Hadoop one dot no big data.com. Port, this is the default one, and login is student. Password already told. Password mentioned. Let me just remove password thing from. Okay. Right. Okay. And if you want to copy the files from your local system to Hadoop 1, not HDFS, I'm talking about Hadoop 1, in those cases, on Windows, you can use a binary called WinSCP. Oh, great, great. Sasikanth is able to logged in. Excellent, excellent. So, are you in the same network, Sasikanth, as others, or you are on a different network? Great, great. So, maybe you can help out others also and tell how to access and then start using. Which means in browser also you should be able to use. So, you are on Linux or Windows, Sasikanth? Oh, okay. So that means if you are able to log in, that means, but that's a command SSH you have typed, right? That means that's a command, not putty you are using. Okay. So if Vishnu is able to open through the browser, are you able to see the HDFS file system, Vishnu? The one which I showed you like this, like this. Are you able to see this? You click, you see this screen? Good, good. Vishnu, you are also in the same network? Great. So which means the firewall problems are not there. It is just the syntax problem you might be facing. So try. I will also send the word version or PDF version of the document to you guys, and you can use that one. All right. Okay. So Putty, probably you are putting a wrong URL in as a wrong host name. Host name should be hadoop1.nobigdata.com. Try that. Okay. Or maybe on Windows specifically is having a firewall client there. Some thing is there. Okay. So people are able to access through the browser, but not on Putty. All right, all right. So somebody who is not able to, so Vishnu, Vishnu, let just so Vishnu, could you ping me after the session? We'll have a look at your machine, and then once that is fixed, you could help out others also. Okay. All right, great. Let's move on then. I will just show you. Okay. Now from the command line, we can copy a big file onto the file system like this. Command line as in Hadoop one. Okay. Hadoop fs move from local a file to this portion. As you can see here, this portion is our HDFS file. Okay. And let's just say, let's see what error do we get. Okay. It says the file is not there. Let's see. So okay. Okay. In this you can see there is a big.txt here. Here there is a big.txt file available in the local file system of Hadoop 1. I'm copying a Hadoop fs move from local. Instead of move, I'll just do copy because okay. So this way it says there is no such folder or directory. Let me just correct it. I will just say sgiri and then say word count. So this way I have copied my file from local to HDFS. And how do I check HDFS from here? From using the command. All right. All right. Now it should show me. Now I'm trying to do ls. I'm trying to find out the files user student sgiri word count. That's right. Users, not users, it's user. Great. All right. So this is how you can copy the files. You can see that the big.txt has been copied. The first item on the top, it has been copied by me from local Hadoop to HDFS. All right. So that is how it is. So please create your own folder in HDFS before you start working. Okay. Right now, we have purposefully kept a common user login for each one so that you can assist each other and also see see what exactly people are doing over there. Okay. All right. And if you wish, for the project work, we can create separate account for you guys. Okay. All right. Now we could also execute pig and hive command just like this and do the work. All right. So into this command prompt, instead of going into pig and hive, we can, to launch pig, we can just say pig here. Now we are inside the pig. This is pig. Okay, we can write our command, load this, load that. We can also launch hive. Okay, so this is hive. Hive is launched. And if we have to launch hbase, we can launch hbase shell here. The console of hbase, which we can do that. Okay, this is going to be problematic. So do you guys have, by any chance, do you guys have access to a website called keepvid, keepvid.com? If you go there and put my YouTube URL, you can actually download the video. And actually we have taken the server space from Google. We have taken the our professional version of the YouTube, where we can upload far more data than possible. Okay, so that is the reason we are keeping it on the YouTube for more reliable networks. Okay, but and we've okay. Let me try to figure this out. What to do with these kind of policies? Okay, so you can just press Control D at any prompt to get out of it. Control D or Control C. I'm talking to Shashikant. How to get out of Grunt. All right. Great. So just to get a feel of a Hadoop command line, what you can execute is this one. Okay. So basically this is how you generally execute, right? So it's saying that output fold file already exists. Let me just say ITC. Hadoop jar. Here you can see what I'm doing is Hadoop. I'm telling Hadoop to execute my code. This is my code. Okay. This is the code which is there already as an example, and telling that this particular program it needs to execute. These are the arguments to my jar. Okay. And as a result, my after reduce, this is where my output will be stored. Okay, in the HDFS. So you can see that the map reduce is being executed. There is a URL to track it. Okay, and there are one task has failed. Now it is forking the same thing onto another task and getting it executed. Yeah, so in the keep wait, just right click, first copy the URL from our website. From our website, just copy the URL of the video, and then paste it in the keep feed and start downloading. Okay, it is okay from our side to download our videos, but it would be great if you don't share the videos with people who have not bought the course. Okay, and in case you are sharing, just let us know that you are sharing with people. Okay, all right. Now, okay, so this is how you can execute a MapReduce command. Exact syntax. All right. Now the important thing which we wanted. So let's discuss it tomorrow. How to think in terms of map and reduce. And today we conclude with the question saying, if you have a big plain text file, imagine you have big plain text file. How would you find the frequencies of words? Meaning, how many times a word has occurred in this text? How would you do that programmatically? All right, or howsoever you want to do it, how would you do it? Okay, so we conclude today's session with this question. Think about it. Tomorrow we will discuss this question and we'll get into MapReduce. Okay, okay, let me repeat again. Let me repeat. So you are given a huge plain text file. You are given a huge text file. Now what you need to do is find the frequencies of distinct words. Find the frequencies of unique words. Meaning, how many times a word has occurred in this text, you have to find that. Alright? Not really. The objective, I'm not looking for an MR. Howsoever you would do today, whether using SQL, whether using program, whether using Unix, whether using Excel sheet, howsoever you want to do, you explain. Okay, and think about all possibilities of the solutions. Okay, if your boss today asks you this work, how are you going to do it? Okay, it's up to you, absolutely up to you, whether you want to write a Java program, or you want to write a program, or you don't want to, just want to use some tool. I'm okay with anything. All right, it's just I'm looking for different kinds of approaches. All right, I'm looking for different kinds of approaches, and we will discuss the good and bad of each approach as our data grows. How will your approach work when the data grows bigger? And in case our problem statement changes a little bit, how will your approach change? You can go for SQL. Yes, that's pretty much accepted. All right. So this is how we conclude today. And those who are, I mean, Vishnu, I mean, will it be possible for you to give me 10 minutes after this session? All right. All right then. Okay. So I conclude here and I look forward to see you tomorrow. And it's really great class, great session out of all the classes I have given. I'm getting really brilliant questions and happy with with the session. All right. Great. Thank you guys. Thank you. And keep asking questions. Drop us an email at hadoop@nobigdata.com so that we can quickly answer your questions. All right. Thank you guys. See you tomorrow. Bye bye. Bye. Have a good day.